Hello and welcome back. In today's lesson, we are going to look at subroutines, which are also known as functions. So go ahead and download the file 06 subroutines function zip and put it in your Fastens project folder, and then unzip it. And delete the zip file. Now you have a new folder, 06 subroutines functions. Let's open it. And you will see there are 4 files here. One is the add2nums awesome file, and another file, add2nums with functions. That means this file is written not using any functions, but this program is written with functions. So let's take a look at the first one first. So this program prompts the user to enter 2 numbers, adds them, then prints the result. So let's run it. Click on Run, compile, and let's go to this folder. After compiling, you have this file, exe file. Type dir to list the directory and you should have this file. So let's run it now. It prompts enter first number, so we enter 3. Press enter. You can enter any number. Then it prompts you to enter the second number. Let's enter 5. And again, you can enter any number you like. Press enter. And it prints result 8. So it took the number 3. It took the string 3 and converted into a number. And then it took the string 5 and converted it into a number and added the 2 numbers to produce 8. So let's see how it works. So we have a few strings here. The first 2 strings, enter num1, is to prompt you for the enter first number. The second string, enter num2, is to prompt you to enter the second number. And the third string output message is to output the result. And sum is an integer or a number. It is used to store the result of adding the 2 numbers together, and it is initially set to 0. So over here you have 1, 2, 3, 4, 5. We have 5 numbers. DD means data, double word. DB means data, bytes. So double word here are numbers, so we are declaring 5 numbers. So the first 2 number is for storing the input handle used by the Windows API function. The bytes read is to keep track of how many bytes are being read by the Windows API called read file. And then number 1 is to store the number that has been converted from the string. So when the user enters a string, it will be converted to number and stored here. Same thing with number 2. Input string is the string that is being read. For example, 3, it will be stored in its input string first before it is converted to a number and stored in number 1. And input string also stores the second number as a string before it is converted into a number and stored in number 2. When the program starts, it will ask the user to enter a number by printing the prompt enter num1. So here, enter num1 will print enter first number. Then over here it will read the number which the user enters. So the user will type 3, which is a string, and the string is 3 is stored in this variable input string. Thereafter, you use the string to OUL function to convert the string into a number on base 10, and it will be stored in EAX register. And over here we save the EAX register value in a variable called number1. So number 1 will store the number 3. Then it is the user will then be prompted to enter the second number. So the user types 5 5 will be stored in input string, and again it will be converted into a number. So 5 will be converted in number and stored in EX, and we store this number into another variable called number 2. So number 2 now stores 5, and number 1 stores 3. Now we are going to add the two numbers. First we zero out EDX because we are going to use EDX to sum up the numbers, and we add number 1 to EDX and store it in EDX. So the number 1 stores the value 3, and EDX is 0 initially. So 3 plus 0 is 3, and the result 3 is stored in EDX. So EDX now becomes 3. Then we take the number 2, which contains the number 5, and add it to 3, which is in EDX. So 5 plus 3 is 8, and the result 8 is stored back into EDX. Then we copy the sum EDX into another variable called sum. So 8 is in EDX, and it is now being saved into sum, so sum now becomes 8. And now finally we print the result by pushing sum into the stack and push the output message and then call printf. So these are the two parameters to printf. So output message contains this string and a format specifier D. So %D is used to print out numbers, and it will be replaced with sum. So you get the result 8. So as you can see, this program is quite long because we are repeating a few things over and over. For example, here we are repeating this part here. Read the number and convert it into string. So there's a better way to do this. We don't want to keep repeating things over and over. So what we can do is we can take this and convert it into a function or a subroutine. An improved version is over here. So in this second version, I'll put this on the left and this on the right. We have taken this out and put it into a function. So this is where the function is from here to here. Function getNum starts here and function getNum ends here. And we give it a label. So this is the name of the function or the subroutine. And you can see now this part here where we read from the console is found over here. And this part here where we convert string to number is found over here. And then we have something new here called return. So the function runs from here, and when it finishes executing, it will return. It will return to the caller. Now our code is shorter. Instead of writing this, now we just have to call the new function here. So one line here replaces all these lines here. So when we call getNum, it will jump to the function, execute it, and then when it hits the return instruction, it will go back to the next instruction after the call, which is move. So this function, when it finishes, it will store the result in EAX. That means EAX will contain the number. The last function inside this getNum is to convert the string to a number, and that number is stored in EAX. So when we return from this function call, we will now store that EAX into the variable number 1, just like what we do in the original program. After that, it will prompt the user to enter a second number, and then it will call again getNum. Once the function returns, it will store the value in the second variable, number 2. Now notice that once you finish with the second call to the function and store the result of the second number in number 2, you are now ready to go to the next part of the instruction, we should now jump over all this function. So we do that by using a jump. In jump output result, we jump all the way past this function, come down here. And over here, it will add the two numbers together. So it will first initialize EDX to 0, and then it will add the number 1 to EDX, add number 2 to EDX, and then move the EDX into the variable sum, and finally print the result. So now our code is shorter. We don't have to call these few lines twice. So our code is shorter. As you see in the original code, you find these two lines here, these two functions here, and it is being repeated again down here. But over here, we replace those with one call, and here is another call. So these two calls make it short. So now the code is neater and shorter. Okay, there's another new thing here. Notice that inside the function, I added these two lines, push EBP and move ESP to EBP, and then at the end here, I also added this one line, pop EBP. Now, when you're writing your own functions, you should always do this. This is called the function prologue, and this is called the function epilogue. The reason why we do this is because we want to preserve the register EBP. Why do we need to preserve EBP? Because EBP is used as a pointer to the stack frame. What is a stack frame? A stack frame is a part of the stack which stores the main program and any of the child programs, child functions which are running. So for example, when you first start this program, this whole program starts from the start entry point. So the entry point will be pushed to the stack by the operating system. And the entry point will have its own base address, which is stored in EBP. So when the main program calls another function, it will then move to execute the function. But when you go to execute the subroutine of function, the subroutine of function might corrupt the EBP, but maybe using it inside itself. So to maintain the original values in EBP, the child function will always push the original EBP value to the stack to preserve its original value, and then will pop it back to restore the original value when it finishes. So that is why we need to do this. And what is the reason for this line? So this line is optional. Now why we use this is because we want to use ESP inside here. So ESP can be used inside a child function or subroutine when you want to create local variables. But in this case here, we are not creating any local variables. So for now, we can just ignore this since we are not creating any local variables. But it is good practice to have a habit of writing this as well. So whenever you write your own user-defined functions, be sure to add these two lines plus this line. Now if you recall, in the early lessons on unpacking, we also saw that we need to keep a lookout for EBP, push EBP and pop EBP. So now you understand why we need to write this when we are creating our own user-defined function. So if you forgot about the unpacking, go and revise the unpacking chapter lessons where we discuss why we need to keep track of push EBP and pop EBP. So that's it for this program. Let's take a look at the second program. The second program is a loop program which we studied before. Let's compile it. And now we have a loop exe. So let's run it. Let me clear the screen first. And then run the loop. Enter number. And then let's say we enter 5 and it prints 1 up to the number that we entered. So we did this before in the previous lesson, so I'm not going to go through it again. So remember this loop. Now this loop is quite long because we implement the printf inside here. So this makes it longer. To make the code more neater and more efficient, we can factor this out and put it in a separate function. So let's take a look at the function version of this program, loops with function. And over here you see now we have a call to print kernum. Print kernum is a function which defined here. So notice now, instead of these 4 lines, we replace it with one single line. And we factor out this into a separate function. And notice here again, we have this function prologue and the function epilogue and the return keyword. So whenever this loop runs, when it comes to call, it will call this function to go and print the number, and then it will return when it finishes. So when it returns, it always returns to the line after the call. So this is how the return works. Alright, let's run this. Let's compile this and run this to make sure it works. So now let's try the version with functions. Enter a number, let's say 6, and it works. So okay, so now you know how to create your own functions and subroutines. So try to convert any program you want, which you've learned before, into another version using functions. So that's all for this lesson. Thank you very much. I'll see you in the next one.